Hey everyone, it's been a few weeks since I've done a video. I've been pretty busy lately with traveling for work, working on Cal, my voice assistant, and also developing a new AI-powered application, which hopefully I'll be able to show you in a future video. But I'm back now and hoping to get on a more regular schedule for releasing videos again. And in this video, I want to go over how I've been training Qwen 3.5 for specifically tool calling and how I'm using Vast.ai, a cloud GPU provider, to do that. So let's get into it. So I've been fine-tuning some small models for a few months now. I started with Minstrel 3, 8 billion parameters, and I was training it using this card right here, a 12 gig RTX 3060. And that worked for a little while. I got some good results with it. And I showed that in a previous video, how I was doing that with simple examples, just one-turn examples. But I quickly outgrew the 12 gigs of VRAM that's in this card and had to move to something else. And there's two things that drove that higher demand for VRAM. One was that I switched from Minstrel 3 as the base model to Qwen 3.5. It's a better base model, more sophisticated, better at naturally calling tools. And the other thing is that my training data became more sophisticated. So on the first point, I use Unsloth to do my fine tuning. It's a very popular package to do that. And if you look at their guide on training Qwen 3.5, come down here, it says it is not recommended to use QLoRa 4-bit training on the Qwen 3.5 models, either the mixture of experts models or the dense models, due to their higher than normal quantization differences. So that means that full BF16-bit needs to be used for training Qwen 3.5, and that makes the VRAM requirement way higher. So there's no way that was going to fit on the 12 gig 3060. The second point on the training data getting more sophisticated, I went from single turn examples, user request, tool call, user request, tool call, to full multi-turn conversations where I include the entire system prompt, all the tool definitions. I include previous conversation history in the example, and then do multiple tool call examples that it trains on. So it might do 3 tool calls in a row in order to satisfy the request. So I'm going to show you those training examples in a minute. But between those two changes, the BF16 quantization requirement for training and the more sophisticated training data, that pushed the VRAM requirements up from what fit on a 12 gig card to using up to 75 gigs of VRAM, which you can't even get on a consumer card. So the answer was going to a cloud service. And the service I'm using is Vast.ai. Now, they're not sponsoring this. I'm not getting anything out of this from them, but this is just what I'm using. And it actually came from a recommendation from a previous video. One of the viewers mentioned it in a comment, and so I checked it out. So thanks for that. So Vast.ai is basically a marketplace where people can put their GPUs up for rent on this marketplace, and other people can rent them and utilize them. Before I show you how Vast.ai works and how my training pipeline works, let me show you the actual training data. So here's one training example, and I'll show you what the actual raw JSON looks like. It looks like this. And I store all the training examples in JSON, and then they get converted in the training script to whatever format is required by the model. So whether I'm training for a Minstrel 3 model or Qwen 3.5, it's the same training data set. It just gets rendered a little differently for those models. So these examples would be one line item in this JSON-L file, but I've broken it out here to make it easier to look at. And I'm actually going to run you through this step by step to show you how this works. This is a 3-step tool call. So this is for my voice assistant, and it's training for the custom tools that voice assistant has available. In particular, this one's training on 3 different tools, which you'll see. So the user message is email Sarah the next F1 race. And the first step is for the model to call a tool. So we give it that example, call the ESPN tool with the arguments, schedule, and the sport is F1. The tool returns a response. It says next up is Australian Grand Prix, and after that, the Japanese Grand Prix. Not the actual dates for 2026 schedule, but close enough. And then step 2 would be to find Sarah's email. So it uses the Google Contacts tool, and it searches for Sarah, and then that tool would respond with her email. Now this is made up. I don't know Sarah Jones. So Sarah Jones, if you're watching, sorry for using your email address. And then the third step would be using the Gmail tool. So using Gmail, it then uses the email it just found and sends an email with that race schedule. The tool says it's done. And then the final response from the voice assistant is that I've emailed Sarah and the next race is the Australian Grand Prix. So that's the full example. And so the model's now learned that F1 uses this tool. When looking up a user, it uses Google Contacts to find their email. And then it combines the information from step 1 and step 2 in the Gmail call. So it learns all that. It learns the custom tools that it has available and how to use them. And this is, again, what that looks like in the raw JSON. And when this gets rendered into the actual training format for the model, it'll also add the full system prompt and all the tool definitions ahead of this example for every single example that it sees, which is why it moves the token count for each example from a few hundred to on average about 7,000 tokens per training example. Hence the larger VRAM requirement. But I'm training in a much more production reflective environment. It reflects a production environment a lot more. Now, I went through some trial and errors with this, and one issue I came into when trying to include all this previous context, and I'll show you another example here in a minute, of all previous tool calls in a conversation history, and then the one I actually wanted to train on, it was actually training on everything. And then Qwen 3.5, the output of that, it was just calling tools for everything. You asked it something, tool call. You wanted to know the capital of Japan, tool call. It just fired off tools right away. So changed the approach a little bit, and I'll show you that here, where it's only training on the last message. So looking here at another example, we include all this context, and then we have the training signal. So above the training signal is a bunch of previous tool calls. So here's the F1 tool call we just looked at. That's one user request. Then we have another user request here to get the jet schedule and send that to David. Okay, that's another user request. And then one more to get the temperature in Melbourne. And so there's 3 previous user messages in the context that it sees. So this would be like a realistic chat history, but the model's not training on that. It's not getting graded on that. It just sees that as part of the training data to go, okay, I see all this previous messaging, but now I need to just focus on the most recent user request. And this one is asking about an iOS update, and it uses a web search tool to find the answer and responds to that. And that's what the model will get trained on, is just specifically this tool call. And this approach was a big unlock for me and the Qwen 3.5 model. Once I went to this approach, where I had the right split between previous context and the actual training data, that made the model just so effective, up to like 99% on the test that I wrote for it, where it's calling the right tool, it's having conversation where it should have conversation, it's using its own knowledge where it should use its knowledge, and it's using tools where it should use tools. Now let me show you how I actually do this. With Vast.ai, I'm going to actually set up an instance. I'm going to use my setup script, and I'm going to start a training example. So in Vast.ai, once you're logged in, you have some credit in your bank, you would search for available GPUs. Now I use this base image. You can select one that's right for you, but this PyTorch I found had the basics of what I need to get going, and then I add my own packages like unsloth that's required. I'll show you that in a minute. So you select the base image, you select how much storage space you need. It's going to be 48 gigs. Then you select a GPU. So I have this filtered just for 5090s right now, but you could select, you just want A100s or H100s if you need 80 gigs of VRAM, which I did for the 9 billion parameter model. But I'll just kick one off with a 2 billion parameter model. I'll show you how that works. It's the same pipeline. So I'll select 5090 and see all the different available ones here and the prices. Now, one thing I look at is the network speed, because when I'm downloading the base model to train, and then when I'm downloading the completed model to my computer, I don't want it to take forever. So I look at the network speed, and it's not a huge price difference, like 10 cents an hour difference to go from a 500 meg upload speed to a 6,000. So let's go with this one in Texas. I'm going to rent that. And then if I click over to instances, I'll see this is creating the image, and then it's going to start up and we'll be able to SSH into it. Okay, it's ready. I could open it here to open up a Jupyter notebook. I don't use that. I just connect with SSH, and I would just need this part right here to do that. You have to set up SSH key ahead of time under keys. So you would use your computer's created public SSH key, put it in here, and then it'll recognize that you are who you say you are and allow you to connect. So let's connect to that. Say yes. And now I'm connected to that machine. So there's nothing in this folder right now, but this workspace folder is where we're going to put all of our files. So it's running tmux, and I also run tmux, so I have like a nested tmux situation going on here. Now you could now set up your environment, so we would need to install unsloth and make sure we have Transformers 5 installed. We saw that in the requirements that we need Transformers 5. That's the default for unsloth now, so you don't have to worry about that when you do install unsloth. When I first started doing this, I had to make sure I had Transformers V5 with a different version of unsloth, and it was a bit of an ordeal, but now it just works. So you could set up unsloth, and then you could SCP to push all the files up that you need to train with, and do that every time. Or you could set up a setup script, which I've done. So I have a script, which is Vast.ai setup. So I can go Vast.ai setup, and all I need to give it is this instance here, instance number, and it's going to connect to the SSH server, and it's going to push all the files that we need up to the server. The system prompt, the training data, all my different training scripts. It's going to now install unsloth into the virtual environment. This takes a minute or two. Okay, now it's validating that everything is there. And we have unsloth, the March 17th version. And now it says we can connect here, and it gives us even the training command we would run potentially. So the way that script works by just giving it the session ID is it runs the command line. You can install this Vast.ai command line tool, and you can go SSH URL of that instance, and it'll give you the URL and the port for that. So it uses that tool inside the script to find the SSH URL and the port, and then uses that to SCP all the files up, and then it also uses that to run the install commands on the server. So now if I connect to that server, I can SSH, I just need this bit here. And I can see all the files are now in this folder. So let's kick off a training run. So it's a Python script, and it's the train Qwen v2, and I'm going to train the 2 billion parameter version of the model. And I'm going to use the training data round 7. I've been through a few rounds of this, and I'm going to output it to this output folder. So this should kick off. It'll load unsloth. It'll download the model. There it goes. It's downloading the 2 billion parameter model, 4.5 gigs. This is the 16-bit version of it. And now it's starting to train. So we're training on a 5090 with 32 gigs of max memory. We're doing 2,600 pairs twice, so 2 epochs. And the batch is 4 times 2, 8 effective. So that's how it batches up the examples and gives it to the GPU. This is how you can manage VRAM by splitting up the batch sizes. And we have a max sequence length of 8,000 K. That's actually probably too short. I think some of my training examples are up to 10,000, and in which case they get truncated. So I need to look at that for this script. I don't think that's set up right for the 2 billion parameter model. So after fine tuning is done, about 1% of the 2 billion parameters are going to be our new fine-tuned parameters that get attached with the LoRa. So it takes a bit to get going. Right now it says it's going to take 13.5 hours. It's not going to take that long. See, it's down to 8.5 already. It'll settle in around 3, 4, 5 out of the 650 here, and then you'll see a true time estimate. That'll be closer to the realistic time estimate. Now I'll often kick these off at night and let it run overnight. I don't want to sit here and watch it for 7 hours, 6 hours. So I kick it off overnight. But when it's completed, how do I know? And if I wake up in the morning and it's been done for 6 hours, I'm just spending money on that GPU rental for another 6 hours that I don't have to. So we have another script that's going to be used to pull this server to check if it's done. And if it's done, it's going to download the model, and it's going to shut down the GPU instance so that we're not spending any more money on it. Just the small, like 3 cents, just to have it running in the background. It's probably less than that for this 5090. So let me show you how that works. It's another script in here. It's my poll Vast.ai train script. I need to clean all these up, but that's the one it is. And the way this one works is you give it the instance ID as well, and the output directory where you want to save it, and how many minutes it's going to take to train. So it won't start polling until 80% of those minutes have passed, and then it'll start polling to see if the model has been trained or not. So if we back out of this and start this script, give it that instance again, this one here, and say we want to go to models, and we'll output it to Qwen 3.5, 2B, LoRa, 2026, 03, 29. And I won't put a time here. I'll just show you how it polls. It'll check every 300 seconds to see if it's still training. And what it's checking for is if there's a file created on the server, it's basically just a done.txt file that gets created at the end of this training script. So this is polling for the existence of that text file. Once it finds it, it will download the LoRa folder and the exported gguf model file that happens to get created on the VPS after the training is completed as well. So what I would do is run that, but I'd give it a time. And this said it was going to be done in 5 hours. So I could give it 300 minutes. Did I say seconds before? This is minutes. Give it 300 minutes. And so it's going to sleep for 240 minutes and then start polling after that. And it's going to output to a file name that is created on the server for the actual model. And it's going to put the LoRa in the folder that I specified up here. And after it downloads it, it will shut down the instance, and then it's done. I actually kicked off one of these training runs from an airplane the other week when I was on my way to Mexico on a WestJet flight. They had Wi-Fi, and I was on my laptop, set up an instance on Vast.ai, got the training data that I had just updated, kicked off the training run on the airplane, and closed off my laptop. The poll script was running on my local server here. And then when I landed and got to the hotel, the training was done and the model was downloaded. So let's look at what this is costing. So I said it was going to take about 5 hours to train that 2 billion parameter model. This is costing $0.428 every hour. So about 43 cents an hour times 5 hours, $2.14 to train that model. That's pretty good. Compared to the cost of a 5090, which if you can find one, go between about $3,000, $5,000 Canadian. I think I'll choose the $2 to train the model. Now for the 9 billion parameter model, what were those? Let's look at what the bigger GPUs were going for. Let's go A100 or H100. Let's look at A100s. So 80 gigs is what we needed for the 9 billion parameter model, and that training data and that approach. It took 75 gigs of VRAM. So we need the 80 gig version of the A100. There's also a 40 gig version of it, but that's not quite enough. And that's $1.13 per hour. And that I think took about 11 hours. So about $12 to train that model. And it took me a few times to get it right. I've spent probably about $100 worth of training credits trying to get all the training data correct, the approach correct, the rendering of the tool calling correct for the Qwen 3.5 model. I was using this to try training a Minstrel 314 billion parameter model as well. So with all the trial and error I've been doing, yeah, I've spent about $100. And so compared to buying a 5090, and even with a 5090, I couldn't have done what I'm doing with the Qwen 3.5 model. So very cost effective. And once you have your training pipeline set up, it becomes very cost effective because you just kick off a new training run with new training data or the slightly different approach, and you can get it streamlined with these training scripts. And I've been using this same approach. So for what I showed you was the training data for my voice assistant. I've also been using this exact same approach for another AI-powered application that I'm developing, the one I mentioned earlier in the video that hopefully I'll be able to show you in a future video. But I'm using this exact pipeline to train that model as well for that application. So this technique is transferable. All right, hopefully that was helpful. And if you want me to go into more detail on anything, let me know. And if you want some of these scripts, I can look at sharing those on GitHub if that would be helpful for people, the setup scripts. And in the next video, we're going to be looking at this 2 billion parameter model running on the Zima board. So in the last video I did on the Zima board, I ran out of VRAM on the little 2 gig GT 1030 card and didn't have a big enough power supply to run the 5 gig GPU that I wanted to run, the P2200 Quadro. I now have the bigger power supply. So the folks at Zima Space that make the Zima board, they sent me this 120 watt power supply. So I'm going to try this with that Quadro to run the fine-tuned 2 billion parameter model. And also there's one other thing they sent me that I'm going to try out, but I'll save that for the video. So thanks for watching this one, and hopefully we'll see you in the next one. Cheers.